Hey everyone. So a while back, I put in this pull request for the ML.NET samples repository to include a sample using the ranking AutoML API. And in that PR, Justin, a data scientist from Microsoft, mentions doing something in the sample called thrice training. Here's his comment here. We can demonstrate thrice training within the sample. And the main idea is that we first use the training set to train the model and then score using a validation set, and then we train it again with the training set in the validation set, and then we use a third test set to score our data to get our metrics from. And then once we get the performance information from that, we train it again using all three different sets, and then this is going to be the final model that we launch to production. And down here he gives a couple examples on why this is actually useful. The main reasons are if we have a small training set and we want to include all the data as much as possible, and also if the data set is split by different ways, such as time, where you're not getting all of the data that's representative within your train set. Another explanation that I think is quite helpful is from the Hands-on Machine Learning book by Aurélien Geron, which I hope I pronounced that correctly. And I'm briefly quoting here, but in that he says, the new holdout set is called a validation set, and you train multiple models using various hyperparameters on the reduced training set, and you select the model that performs best on the validation set. After this process, you train the best model on the full training set, which is the train set plus the validation set, which is what Justin mentions up here, and that gives you the final model, and then you can evaluate the final model on the test set to estimate the generalization of the model. So that's a little bit different that we're doing here. At the end, we're using all three sets to do the training, and in the book he mentions doing these two, and then testing on the final test set so you can see how well it generalizes. Alright, so I'm here in a .NET Core Console project, and I already have my data in here. I'm using the housing data, and I know I use this data a lot, but I like using it, and it's useful for pretty much most of the things I show here. But I already split it into three different files here, and right now, currently we have to do this split into different files because unfortunately there isn't a current way to merge our data views at the moment, but I think that is something that's coming at some point. And real quick, we can show how I did this split. I used Python for this, using NumPy and pandas. So I read the original file using pandas, and then I used numpy.split to get my train, validate, and test sets. You can see here our train data has about 12,000 rows in it, and our validation and test set has 4,000 rows in it. Then I use pandas again to create data frames and save those to their own files. Alright, so first thing, I need to install the AutoML package, and we're using AutoML for this. So Microsoft.ml.auto using version 17.4. Alright, so that's loaded. First thing first, as always, we create a new ML context. There's a couple ways we can load in our data here. First, before we do that, I'm going to add a few private static variables here. So first, private static string, I'm going to add the train data path. That's going to be house train.csv. I'll do the same with test and validation. So house test and then house validation, or house validate. I think that's right. Yep, house validate. I'm going to do one more, and this is going to be the label name, and that's going to be the median house value. So we have those. Like I mentioned before, I'm going to load this a couple ways just to show that this can be done. First, I'm going to show using the text loader options. So new text loader dot options. We give it a separator, and this is a character array. So new, and I can do it inline like here, so it's going to be a comma. Next, I'll set if it has a header, which is true. Then next, I'll define the columns, which is an array of text loader column. And here, the first parameter, we can give it the column name. So I'm giving it a column of features, and we can do that because one of the overrides here is, well, okay, first datacon is going to be single or float, and then this one we set a single index for the column, but we can also set a min and max index to get a range of columns. So I set 0 for the min and 7 for the max index, so to get the range of the first to the 8th column. So I do another one, new column. Next is going to be the label. That's going to be datacon single as well, and that's going to be the 8th index of the column. And then last, we do one more column. It's going to be the ocean proximity. This is going to be a string, and that's going to be the 9th index. So we have our text loader options, and we can create a loader from that using context data that create text loader, and then do our options like that. And then from the loader, we can get our loader data by using loader.load on our train path. So that's one way to do it. It's kind of a long-winded way, and we still have to define our columns. But if you remember from a previous video, we did something that's actually easier than this, and that's to allow AutoML to infer our columns for us. So to do that, I will get an inference, and I'll get that from context.auto using the AutoML API, and then use the infer columns method, give it our path to our data. We'll say has header true, separator, character, it's going to be that comma, label column index, it's going to be 8. If you remember, we specify the index because it has this header is true. We can remove that and specify the name itself, but I'll just leave it like that for now. And since we have this inference, we can use that, and then the text loader options from there, and do the same loader.load on our train path. Alright, so we have that. I'm actually going to rename this to train data. I'm going to do this 3 more times. Second time it's going to be on our validation data, and we'll call it validation data. Then on our test data, and we'll call it test data. So we have our data views for each of our data files here. And next we'll create our experiment settings. So new regression experiment settings. Do max experiment time, we'll do 60 seconds. And then optimizing metric will be regression metric.r². And now we're going to do our training. So we're going to do our first training. This is going to be on our training data. And this is where we actually call that AutoML API. So experiment results using context.auto. Then we create regression experiment using our experiment settings, and then we execute that on our train data. And you remember earlier we'll use our validation data for that, and we can get our label column name as label name. Alright, so we have this experiment result, and we can get the predictions on that using the experiment results .best run .model, and we can transform on our test data because we already used our train and validation data, so we're using our test data to get our test predictions on, and get our first metrics using context.regression regression.evaluate method, and we use those predictions and then give it the label name, and we'll keep the score column name as the default of score here. And I'm going to create another method. Say public static void print r². It's going to take in regression metrics, and with that I will just do console.writeLine. I'll say r² is metrics.r², and I'm going to add an environment.new line to help break this up, and I'll say print r² and just pass in first metrics. So that's our first training iteration. Now we can do our second training, and this is going to be on train plus validation data. So we'll load in our train and validation data once again here. So train plus validation data using loader.load. And to load in multiple files into one data view, we can use this multi-stream source overload here. And to do that, we use new multi-file source. And then we can pass in as many file paths in here as we need. So train path and then validation path. Now we'll load in both of these data files into a single data view. And next we're going to refit the model that we had from up here in our experiment results. So experiment results, that best run, that estimator, and then we can fit on that, basically to kind of train it again on our new data view. So train plus validation data, and we can get predictions on this new refit model using that refit model, that transform, and this is going to be on that test data. Because we already used the train and validation data to train on, now we'll use the test data for our metrics. And speaking of metrics, we get those the same way using context, regression, evaluate on our second predictions, and we pass in that label name again, and now we can print R squared for our second metrics. So hopefully when we run this, we'll get an R squared from our first run on our training data, which uses validation data to test on. And then hopefully on our second run, it'll be better because we are using our train and validation data to train on instead of just the training data. So we have extra data for it to train on, so it should be better, but we'll see. And then for our third training, this will be on our train, validation, and test data. Kind of the same process that we did up here. So train plus validation plus test data. We use that same loader.load with the new multi-file source. And then here we'll put in our train validation data and our test path. So it's getting all three of these into a single data view. And then we refit our model on validation data, experiment result, best run, estimator, fit. So it's going to fit on this new data. And we don't have any other data to test this out on, but what we can do is, because this is eventually going to be our final model, we can just do context.model.save, so we can save this model off. So refit model on validation data. We use our train data, schema to save our schema of our data, and we'll just save it to the house model.zip. Alright, so let's run this and we'll check these two metrics and see how those go. Alright, so this finished completing, and we see on our first run we got about 83%, but on our second run we got a little bit better at 84%. So we can see adding that validation data does help it out a bit, and I'm pretty sure if we were able to test on our test data as well, it probably would have been even better. Alright, so I hope you enjoyed the video, and if you did, please give it a like and subscribe, and I'll see y'all in the next video. Thanks.